So first off, good afternoon, everyone. I'm the only thing standing between you and lunch, so I'm going to try to make this as interesting as possible. My name is Lovell Hodge. I'm the Vice President of Data and Adaptive Intelligence at Munich Re. For those of you who have never heard of Munich Re, it is a global reinsurer, about 50 plus countries, and headquarters, surprisingly, is in Munich, Germany. So what I want to talk to you today is about AI and disruption of the insurance industry. And the one way of measuring the importance of AI to the insurance industry is actually by following the money. So if you look at the slide here, you'll see we expect about $1.4 billion in insurance being spent on AI with an ROI of about $390 billion by 2030. So there's a lot of investment in this space. But why? So it's changing the face of the industry because insurers are realizing in order to be competitive, and that's insurers and reinsurers, in order to be competitive, they have to do a few things, right? And they have to start automating things. And that automation, unfortunately, requires automating processes that are normally dependent on human intelligence. So by automating what we call routine tasks, enabling smarter risk assessments, detecting and mitigating fraud, and automatically settling claims and just transforming the customer experience in general. Those are the types of use cases that you see AI and this technology being applied to. Now, AI in and of itself was a solution looking for a problem just a few years ago. So what's driving this adoption? One of the key things that's driving it is actually the availability of data and compute infrastructure. When instead of having massive data warehouses on premises, you can now do most of this in the cloud, and you do have access to ready-made AI algorithms. Carriers are seeking to reduce costs through that intelligent automation, and to do that, there's a lot of maturity in some of the subfields of AI, especially in natural language processing and computer vision. So I promised you I'm going to make this talk interesting, so we're going to look at some of those actual use cases and examples. Now, you've been at the conference, everyone's talking about AI, so this might be a moot point, but I just want to set the tone here. What are we talking about when we talk about AI? So I like this diagram because what it does, it sort of puts side by side what we talk about traditional programming versus AI. The traditional programming model says, look, I'm going to hire a programmer who knows the solution to the problem, and that programmer is going to code that solution, apply it to some data, and then we get an output through our computers. Okay? Everyone's familiar with that. We've been doing that for a very long time. The AI paradigm says, well, wait a minute here. I actually don't need the programmer. Why don't I just show the computer what I'm trying to get to with the data and have the computer figure out what the program should be? Essentially, that's what AI is. So what happens at the bottom part of the slide there is you provide the computer with outputs and the data. The system finds the correct algorithms to give you the outputs that you need, and then it can actually act on data it hasn't seen before, which is where the intelligence, that magical intelligence, comes in. So that's a very high-level view of what is AI. Now, remember I said at the beginning of the talk, well, we're trying to automate processes that depend on human intelligence. So how intelligent is this AI, this concept of AI? We're actually just in the first stages, and we have a lot to look forward to. AI can be essentially separated into 3 stages, stage 1, stage 2, and stage 3. And the stage 1, which is where we operate today, is really talking about narrow intelligence. There is a problem, and we're solving that problem with AI algorithms built for that problem. That's artificial narrow intelligence. What we're striving for is more of an artificial general intelligence where it can, a system can operate across a variety of problems. And of course, the North Star for anyone in the AI field is the artificial superintelligence where we try to achieve sentience. I won't cover anything about that in this talk. So that's where we are, that's where we operate. It is smart, we've done quite a few things. So what I want to do today is I want to talk about 3 use cases. Now, there are a lot of use cases for AI insurance, and there are a lot of opportunities for disruption. But I'm going to cover 3 here that I think might be wide enough for the interest of the audience. So we're going to talk about customer support, claim fraud detection and prevention, and pricing and underwriting. Those three areas are essentially a lot of research, a lot of activity in the insurance industry right now. Other use cases are there as well, but those three seem to exemplify a lot of the effort that's going into AI. So in customer service, the idea here is, we want to make sure that those who have customers retain them, and those who are trying to grow can acquire new customers. The issue is that based on Accenture, at least 170 billion of insurance premiums could be at risk because of the poor claims experience across insurance companies today. And then on the underwriting side, there's a possibility of losing about 160 billion over the same period. So what really the industry's trying to do is to come up with technologies that improve the customer experience. No one gets out of bed in the morning and they're just looking forward to talking to the insurance industry. So what they want to do is they want to supply the consumer with a means of interaction that is quick, efficient, and to the point. And that way they maintain that customer experience. So do we have a problem? Yeah, I would think so. But we have techniques to address this problem, okay? So for customer experience, we can talk about chatbots, where you can achieve that 24/7 always-on paradigm for insurance companies and reinsurers. Service call analysis, where the computer can take, we call it data fusion. It takes service calls from emails, the phone, chats, and it brings it all together and figures out what are the common issues we're seeing. And then those smart people can actually address those issues even before they recur. And of course, we talk about agent support systems to help identify customer needs and predict customer needs so we can address them proactively, okay? So what we're going to do is look at an AI-powered chatbot in action. All AI powered. That chatbot is a product of a fintech out of Australia, actually. And many companies are deploying these chatbots for always-on, superb customer experience. So one of the key points I'm going to leave with you today is AI is disrupting the traditional insurance service channels by bringing that 24/7, always-on, scalable customer experience. Let's go to fraud detection. I promised you 3. This is the second one. So fraud detection is a very complicated problem, and AI is powering a lot of very sophisticated solutions for fraud detection. So fraud, what are we talking about? Who's committing fraud? Applicants, policyholders, third-party claimants, organized criminal rings. Everyone's after the insurance company these days, right? And how are they doing this? By padding claims, by misrepresentation. The point here is that the problem is not singular. It's a complex problem. So how do you solve a fraud problem that's extremely complicated and needs intelligence to actually mitigate? Well, let's see where these fraud vectors come from. Application fraud, synthetic ID. When you fill out an application, you put in material misrepresentation, okay? Claims fraud, dentists overcharging with billing codes. Auto insurance fraud is a huge area of fraud, right? Where fraud occurs with car accidents, people stage accidents, all that stuff. And of course, in the health industry, or health insurance industry, we see a lot of fraud there as well. Wrongful health insurance billing and unnecessary medical practices. All right? Now, the challenge here is that, well, first of all, we're losing a lot of money, but the challenge is that it's complicated. And so you have to have a complicated response to this. And the only way to do that is through some sort of intelligence system. But that intelligence system is not singular. It's a multifaceted system. So how do we do that? Well, we throw everything at it, okay? And the nice thing about AI, it has multiple pillars, multiple facets, all right? So NLP, graph, computer vision, all that stuff comes together. How? Well, think for example, natural language processing. We can comb through online posts for a suspicious activity and have a computer do that and alert you automatically. Graph algorithms. We can learn relationships between claimants and providers, or even criminals and providers, and we can visualize those relationships, and we can learn new ones by sifting through millions of records. Computer vision can be used for identifying suspicious behavior. We have systems that can tell you that the x-rays from the dentist, 2 x-rays belong to the same patient, but the dentist is claiming that they're different patients. We can do that today. Classification and regression models for classifying claims for fraud, because we have historical data that we can train with. And then, of course, we have unsupervised learning, we learn things like impossible days for dentists, right? We can learn dentist dental behavior, or even purchases for medical equipment. And of course, we can sift through millions and millions of lines of data and formulate rules automatically. All of these are facets of AI. All of them come with your own strengths and weaknesses to a very complicated problem. And that's how we try to mitigate fraud. So one example of this is if you're filling out an online form, we can actually track to see how you're actually filling it out. Are you keep strokes, typing speeds, whatever? Are you going back and erasing stuff and filling it in again? We can learn the normal behavior and then alert a user to something that is abnormal. And this you'll see more and more. There's a lot of activity in this area, and you'll see more of this on the market soon. Now, I know I'm going through this a bit fast, but I only have about 30 minutes, so hopefully you got your cameras at the ready. I believe these slides are going to be made available to you as well. So I couldn't leave this topic without showing you a few actual examples, all right, where we've detected fraud using AI. So dentists submitting the same radiograph, I mentioned that before. Here's a lady teaching Zumba classes, but she has a knee injury, and she's actually teaching the class, she's not actually participating. Person on LTD for back pain, doing cross-country motorcycle riding, and then conducting online business in a no-op situation on LTD. Now, all of these cases were detected using artificial intelligence, sifting through millions of images and posts and texts, and alerting the agents to those activities. Fascinating. So, current fraud detection is actually done after payment. This is the issue, right? The most expensive part of fraud mitigation is actually the recovery, right? Going after the money. So in a typical traditional system, the fraud is detected as an investigation and then some sort of recovery, all right? What we try to do with AI is a slightly different paradigm. What we say is, well, what if the AI actually can stop the money from going out so you don't have to depend on the recovery? And this is a fascinating thing because certainly your costs are going way down, right? Now, you do have some situations where you actually pay the claim, but you do an investigation after, which prevent further claims of that nature. And that happens as well. And what happens, because of that feedback loop at the end, the AI system actually gets more intelligent over time. So this is a fascinating application of AI, and we are having a lot of fun with it now. So to leave you with a thought here, it's disrupting the traditional fraud detection paradigm, and it allows the insurers to focus on prevention rather than recovery. A lot cheaper proposal for them. So let's do the third use case, insurance pricing and underwriting. And I promise you, I'll show you an AI in another AI in action as well towards the end of this. Insurers are adopting automated underwriting platforms because they're efficient, consistent, and cost-effective. Okay, they can scale. And instead of hiring an army of people, the AI can actually complement the traditional actuarial and biometric processes, which really operate on aggregate data, right? They operate on a high level. But what the AI allows you to do is build behavioral profiles at the client level. So you can actually do a bottom-up approach to risk assessment and pricing as opposed to the top-down approach, which actually is a lot more accurate, right? So we can provide predictions on the utilization of plans and the cost of the plans, especially in the group space. This is an area that folks are very concerned about. But we're going to the individual level, we can actually predict what that utilization of a particular policy or plan would be. And of course, that's extended to the pricing experts. So here's an example. This is an actual result, by the way, that we're working on. So here, in the dental space, right, for a group plan, we can actually predict the number of claims and the cost for the group based on age, right? So we bin each policyholder into age groups. And we can do this in many ways. Age is just one slice of the data. But to bring your attention to the orange graph is what the model is predicting for count and cost. And the green one is what is actually observed in the data. And you can see the model is actually quite good at this. Now we're still tweaking it, we're still doing some work on this. But this is the sort of predictive stuff that kind of makes sense. So you can think of it from a pricing perspective. Now, you can do what-if analysis, you can do all sorts of stuff. The use cases are actually endless on this. But it's an amazing technology. So AI can also be used for semi and fully automated underwriting and monitoring of policies during the contested period. And in fact, by things like scraping the web and social media, you can actually monitor for activity that might be antithetical to what the policy says. So that's an area where we're doing a lot of research. In addition to that, what we also want to do is extract information from a lot of unstructured data. That has been a very big challenge for most of the industry. It's not a new challenge, but it is a challenge that's being met by new technology. And so in that area, we've done a lot of work and continue to develop algorithms there. So what does that mean? APSs, attending physician statements, claim forms, doctor's notes, application forms, even obituaries, and I have an example of that. We can read these documents, read the unstructured text, and make inferences from them as if a human was sitting at the desk. This is very powerful stuff, okay? So here's an example. Here's some labs. And you can see this is very dirty data, right? So the system has to read this, extract the relevant information. We tell that system what is the relevant information in hemoglobin, et cetera, et cetera. What is it that we want to extract? So imagine millions of these documents coming through. It's digitized. It's cleaned up using computer vision. And then the appropriate information is extracted, all automatically. No touch by humans. The human is still in the loop, and I'll show you where. But the initial digitization of this is where the AI comes in. Let's take another look at this. This is an APS, attending physician statement. So when you're doing underwriting, especially in the life space, this is something that's very important to you. And you have to, an attending physician statement, I didn't actually know this until just last week. An attending physician statement could be 2,000 pages long, right? So, and it's interesting because we actually pushed one through our system last week and everyone called me and said, it worked. But what we can do on these attending physician statements, you can actually train the algorithms to look for certain things, and those things will be relevant to your underwriting decision. So that's why we do there's a lot of investment in this, because whoever can read APSs accurately, that's kind of like the holy grail, right? So, again, you don't take the human out of the loop. The traditional underwriting workflow says you have your underwriting case files, they go to an admin. The admin may set them up in some sort of document control system. and then that goes to your underwriting case management tool, and a decision is made by the underwriter. Okay, that's a typical manual process today. But there is a significant manual effort, and if you're doing this continuously over a lot of, all day, it can get quite problematic. So not only because it's just a high volume, but you also get errors as well. So if you change that slightly, and you put AI in there, this is how it would work, okay? So you have your underwriting case files, you have your unstructured data, just like what I showed you, right? Your data might be APS or labs or whatever. You want to extract that data with the AI. Now the human is doing data validation. So they would validate the data because you want to be 100% correct, and the AI is not necessarily 100% correct. So you do a data validation function, but that information is already in the system, and then you can also have AI helping the underwriters to make the decision. Now, some teams will say, well, I want the AI to make the decision, and that's quite possible as well within certain parameters. But the typical use case would be a decision support system. Apologize for the spelling there. The idea would be a decision support system that supports the underwriter in making the decision, and it tells them exactly why this case should be underwritten or potentially declined. The underwriter may choose to overwrite that, but that's their prerogative. Fascinating. So we save a lot of operational expense in this, and I think this is an area where there's a lot of global competition to get this just right. Certainly a lot of money being invested here. So what I want to show you here is reading obituaries. I'll explain why the reading of the obituary is important, but let's focus on the actual mechanism for now. Here's an actual NLP system from our labs that's reading the obituaries. It reads millions of them, and the purpose is to classify the cause of death. And what you'll notice in the areas that it's highlighting, the cause of death is not necessarily the same words you're looking at in the classification, right? Like it knows that the liver is part of the digestive system and all that stuff. So by reading millions and millions of obituaries, we've actually trained the NLP system to be able to pick out the cause of death. And that information is used in other downstream analytic processes, but this is the first step in acquiring that information. So you replace this with claim notes to look for a specific injury or whatever. You can train the NLP to do this. And one of the things I will tell you is, I know some of you may have attended some of the other talks on NLP. The good news is that NLP is a fairly complicated area, but the good news is that you have a lot of pre-trained models that you can make use of, and these are, to most extent, free. Right? So things like BERT and Robert and now DALL-E is in there, all that stuff. So a lot of open source models, and they've been trained on corpuses, sections of text, that are millions and millions and millions of lines long. So they have quite a bit of intelligence in the system. And then you can take those and do something called transfer learning, which allows you to apply that learning, that pre-trained model, to your own domain and your own use case. And that saves you a lot of time, right, in trying to develop the model for yourself. As a matter of fact, I was looking at one that was released by Facebook, and it took them 1,000 GPUs for about 6 months to build the language model. You don't want to invest in that. So it's best to use what they've given you, but then train a portion of it for your particular use case. So, key takeaways. AI is a disruptor. We started out by saying that. I hope you're convinced. It can automate a lot of tasks which are generally associated with intelligence. It can perform tasks at scale, right? So you can scale many bots. You can scale this technology up. And I think that that's going to be a significant impact on some of the channels that we have. The claim fraud detection, complicated problem, but we have a solution that's at the right. And I think this is an area that's fascinating. Pricing and underwriting will also benefit, and you can see that by being able to predict the utilization of your particular product, that's going to be a very big, important data point for any pricing analysts in the pricing process, right? So what I would say is as AI techniques evolve, the insurance company is poised to benefit. Traditionally, the insurance company has been slow initially, but as I said in a podcast I did a while back, a few weeks back, it is one of the few industries that you have where AI is applied to a bunch of use cases. So if you think about, you insure manufacturing, you insure medicine, you insure cars, you insure health. If you think about the applications of AI, just in the insurance industry, it touches all the other industries. So it's a fascinating starting point for AI. And with that, thank you for listening. Enjoy your lunch, and it was a pleasure meeting you.